welcome to the lecture on measurement of residual stresses in weldments. So, we talked about the emanation of residual stresses in the weldments, and that is because of the thermal cycling or the temperature through which the zones undergo temperature cycle. So, we must know, we must be acquainted with the methods which should tell us to find the residual stresses in the components. So, the components may be any component, maybe cast component or weld component. So, there are ways to find the residual stresses which are there inside the weldment, and you may have the experimental methods and you may have the analytical method to find the residual stresses in the components. Among the experimental, you may have the destructive methods and you may have also have the non-destructive methods of finding the residual stresses in the weldments. So, we will talk about mostly about the destructive type of methods which are used for finding or for measuring the residual stresses in the weldments. So, the important techniques, the common techniques which are available to measure the residual stresses are brittle coat method, then you have photo stress method, strain gauge method, and also other methods. So, what we normally do is that you have the methods to to measure the stresses, and using that the strain relaxation techniques. So, either the job will be machined or or drilled at a place where that stress has to be calculated. So, accordingly we calculate these stress values. So, if you come to the first method, that is your brittle coat method. So, the concept is that what we normally do is that you provide a coating on the surface and then you do some drilling. So, what happens that residual stresses, as we have understood, that is Locked-in stresses, and they have to be released. So, when you are doing a drilling or machining operation, then these are basically released from there. So, you will have the change in the dimensions also, because they are having under the stress. So, there are different methods, and by that we try to measure these stresses or to know that what is the residual stress. Otherwise, certainly for measuring stress you have the rules. So, you will have the stress strain rules. So, based on that also you can find, but otherwise metallurgically or for the experimental investigation side, we will discuss few of the methods just to have a feeling that how these are measured. So, the first method is what we discussed is the brittle coat method. So, as the name indicates, in this method you provide a coating. So, what you do is you provide a you give a brittle coating. So, you are making a layer of brittle coating. So, that is also known as the stress coat or the brittle lacquer. So, also known as the stress coat or brittle lacquer. So, basically it is a lime wood rosin, and then you have also the dibutyl sulfate. So, so that is with the carbon disulfide as the solvent. So, that is the material for that brittle coating. Now, these coatings are commercially available in the market, so you can have those brittle coatings. Now, what coating has to be, how much when the coating has to be done. So, for that you have the specified conditions are there, like temperature and humidity conditions. So, that on that basis you will have to select the appropriate coating. Now, once you have the coating, then what you do is that you have to clean. So, cleaning of job and calibration strips. So, so they are so what you do is you also give a pre-coating with aluminum, so that you are having a bright background. So, first of all you give these the with aluminum you are giving a pre-coat, and then you provide this brittle coating, so that when this pattern will come out, then you can have the more bright visibility. So, what you do is you give aluminum pre-coating to provide a bright background. So, the pre-coating basically will be drying in some time, maybe close to 15 to 20 minutes. Then you provide this coating. Now, these job and calibration strips. So, that will be, so job and calibration strips are sprayed with the brittle coating. So, then once you give this brittle coating on the job and also on the calibration strips, then they are allowed to dry, and that may take a very long time. So, the drying time is normally about 15 to 24 hours. So, since it is a brittle coating, so that becomes quite hard on drying. So, then now the place where you have to find the residual stresses. Now, there basically you have to locate those places, and then at that place you have to drill a hole. So, what you do is to drill a hole. Normally you take a 3 mm dia hole and at appropriate place, or you have place of interest where wherever you have to find the residual stress. At that place you are drilling a hole of about 3 mm. So, what happens that now once you remove the material, so because of the removal of the materials the stresses are relaxed, and that will be affecting the brittle coat on the material. So, basically that because of that you will have because they are completely adhered to the surface of the work. So, as there will be any so since there will be stress adjustment, so there will be some movement, and because of that there will be cracks will be there to accommodate those movements. So, you will have the cracks on the surface in that brittle coat. So, so the stress relaxed from removed material so that will affect the brittle coat. So, so what will happen, you will have the presence of a crack pattern which will be observed, and the job will be basically stressed to the biaxial type of tensile stresses. So, what will happen if you have suppose a job, if you have a job like this, if you have, this is the suppose a casting. Now, in this case if you suppose draw this drilled hole, so what will happen, you will have the cracks which will be seen like this on the all around this, so that on that brittle coat. So, this will be the crack patterns. So, this is your this is the hole which you are drilling, and this is your work. So, what happens is that these calibration strips are there. So, they are subjected to the biaxial stresses, because you have the stresses which are released, and you are talking about on the surface, you have biaxial stresses are there. So, so you will have the you have the load point of initial cracking, and then your strain in that strain scale, that is also measured. So, what is the change in that dimension. So, you have the calibration strip, so you can understand the change in the length. So, you can measure that way the strain, and then you will have the calculation of the residual stresses. So, basically again you have to use those stress strain rules to find, because these strain and strains in the different directions. So, based on that you can measure the stresses from the empirical formulas. So, this is how you use this brittle coat method to find the residual stress in a component. So, it will be giving you, so brittle coat method normally will be giving you a quantitative estimation of the residual stress close to the accuracy of about 10%. So, that is normally the degree of correctness of the data which is obtained with the brittle coat method. Now, in this case you can and it is also to used as for detecting that static and dynamic strains in tension or the compression. So, what the traits of this method is that in this case the gauge length is very small. So, your gauge length is very small, and also you have the you can have the smallest measurable strain which you can measure is about 500 micro meter by mm. So, that is normally that type of strains can be measured. So, you will have the rate of strain will be something close to 0.05 to 0.15 percentage. So, I mean of that order, this strain value will be can be measured, and that way you can calculate these stress values. Next method which is which we discussed was the photo stress method. So, in the case of photo stress method, so this method is based on the principle of photoelasticity. So, this is based on principle of photoelasticity. So, in that case using the relaxation techniques you can find the stresses in actual objects. So, based on that principle you have here the use of the photo stress coat. So, in this case again you have the photo stress coats are available. So, photo stress coat that will be acting as the infinite number of strain gauges. So, acts as infinite number of strain gauges so normally that will be of practically of 0 gauge length of practically 0 gauge length. So, and you are basically uniformly distributing over the surface where the stress is to be calculated. So, uniformly distributed over surface. So, in this case also again you have the similar type of procedure which is followed. Now, in this case what we do is, so your step is that again you apply the surface of the, first of all your surface will be cleaned and sprayed with aluminum paint. So, surface cleaned and sprayed with aluminum paint. So, again we are doing this to have a very reflective surface and you have a bright surface. So, for that you are cleaning that so for basically for the reflective to make the surface very reflective. Now, what we do here is, in this case we use this liquid photo stress plastic. So, that is applied on that prepared surface. So, liquid photo stress plastic is applied on the surface. So, once you apply this liquid photo stress plastic and then you allow it to polymerize. So, and allowed to polymerize directly on the job. So, so one is that you can have the use of liquid photo stress plastic, or you may have the use of transparent the photo stress materials also, which can be bonded on the surface of the job. So, so that way also you can have the use. Now, this once you have made this, then now this is placed in the so this job thus prepared, job prepared is placed. So, that is in reflection polariscope. So, what we do is normally we again here also we drill a hole, and then so again I mean drilling the hole will be to just have the understanding about the stresses which are there, residual stresses which are there inside the material. So, so that way the strains will be relaxed, and that will be affecting this photo stress coat. Now, what is happening that in this case your so your if you look at the the apparatus, what is there is you have a light source. So, you have a light source here, and then you have a lens system. So, so light from the light source you will be having the light light, and then you have the lights coming through it. Now, it will be passed through a polarizer. So, you will have a polarizer which is there in it, and then you will have so from here again the light comes down, and here you have so you have the mirror. So, one mirror is kept at some angle. So, once it comes here, so it will be reflecting, and it will be reflecting in this fashion, and similarly this striking here, and that also will be going parallelly in this fashion. Now that will be, so you will have the job here. Now if you come further down, so you will have the the stress coat which is provided on a specimen, and you have a welded specimen. Now from here it it goes, so it becomes refringent. So this way it will go, and then you will have the again you have the, you have to these will be passing through the lens, and that you will it will pass through like this, and you can see it on the viewing screen. So you will have this as the viewing screen is there. So again you have in between, you have a polarizer here. So the job is basically this this is the light source. From here this light will come, and the purpose is that it will be turning. So because of the change in the photo stress coating, because of the stress released, so that way it becomes by refringent, so that is doubly refracting, and the plane polarized light basically it will be passing through that affected photo stress material. So basically it will be changed into two two component, that is mutually perpendicular rays, and then they are parallel and perpendicular to the direction of the stress. So you have accordingly you will see these on the viewing screen. So so this on this you will be having the light and dark fringes. So that basically will be giving you the idea about the distribution of the principal stresses which is there on this screen. So when you observe it through the reflection polariscope, what you see is you see two sets of basically bands. So that is seen in that strained photo stress coating. So accordingly you will have those are basically, you have the isoclinics and you have isochromatics. So isoclinics refers to the black bands, so that give you the direction of the principal strains, and you have the isochromatics, so that is the colored fringes which you obtain, and it will be giving you the maximum shear strain, that its magnitude of the maximum shear strain. So you will have so you have only one reading of the fringe with the light going under the normal incidence through that photo stress coat. So so that way you have the pattern of these colored fringes, which is the function of the strain distribution, which will be so here that pattern will be measuring that strain distribution, and and peak of the strain also can be determined. So you can have the location, and you can have the sign and magnitude of that strain maximum that can be measured by looking at the fringes which you get on that viewing screen. So this is the method of the photo stress method which is used for calculating these residual stress values. Now the next method which is used is the the strain gauge method. Now in the case of strain gauge method, so you are again in the case of in the other two methods, you are basically drilling the hole, and you are so measuring those strains. So here also you have the strain gauges, you use the strain gauges, and so strain relaxed will be measured, and then so that is measured again for by drilling a hole into the material, and then accordingly so you will have strain rosettes here, and then accordingly you will have so you will have the measurement automatically of the strains, and based on that you can measure these stress values. So so you will have here you have the relaxed strains are measured with the help of strain gauges. So you have you may have single strain or gauge, or you may have many. So so a single strain gauge so so single strain gauge will be measured for the uniaxial strain. So that is preferred for measuring uniaxial strains. Uniaxial strain, but if you have to measure the complex stress system, then you have a strain gauge rosette is used. So while for measuring principal strains and stresses in job under complex stress state, what you do is you use the strain gauge rosette. Are preferred. So you will have when you have the single one, so you will use for so you will have one one strain rosette. So that is basically there for single uniaxial strain, whereas if you have the for the complex stress state, if you have to calculate, in that case you will have the so in any axis in this domain you will have this different the stress. So this is one, this is the another, and similarly you will have the so this will be this way you will have the so you will have the system of the strain gauges, that is strain rosettes. So they are used basically in these cases. So you will have that is known as the strain rosette. So in this case also what you do is you have to first clean that surface with the emery paper. So you have to first of all you clean the surface with emery paper, and then with acetone or carbon tetrachloride. Now after doing that, what you do is you have to paste that strain gauge or the rosette on the surface. So paste strain gauge or rosette on the surface. So they can be fixed for on any specimen which is welded. So that can be measured. So once you have the drilling of the hole, in that case these strain gauge rosettes, you can measure these strains. So So, basically you have these strain gauge rosettes at the different angle, this is 0 degree, 45 degree and 90 degree, 0, 45 and 90 degree. You have the strain gauge rosettes are fixed. So, that will be calculating the strains in these three principal directions, and then once you know the strains which are measured, then based on that you can calculate the stress values in the specimen. So, so that way use of the strain gauges which are based on the electrical signals. So, you can measure the stresses and understand what is the amount of residual stress which is stored inside the material. So, even after that also you apart from these destructive methods, you have many kind of non-destructive methods also for calculating the residual stress values. So, this is about the calculation methods of residual stresses in the welded specimen. Thank you very much.